Delta-delta with high leg transformers present a unique configuration. The secondary windings are connected in delta and a center tap is brought out to ground, creating a floating neutral or high leg. This differs from the more common delta-Y configuration, which has a solidly grounded neutral. Delta-delta transformers inherently create a voltage imbalance between the phases. The voltage between the high leg and the other phases is the square root of 3 times higher than the phase-to-phase voltage, which can result in voltage stress on equipment connected to the high leg. Delta-delta transformers can generate harmonic currents, especially if the load is unbalanced. These harmonics can cause problems for other equipment connected to the same transformer, leading to overheating and premature failure. The absence of a solidly grounded neutral in delta-delta transformers complicates ground fault protection. In the event of a ground fault, the fault current path may be limited, making it difficult for ground fault protection devices to operate reliably. Removing the grounded tap would essentially convert the transformer to a delta-delta configuration, eliminating the high leg and the associated voltage imbalance and harmonic generation issues. However, this may not be a viable option as it requires rewiring the transformer and may void the warranty. Isolation transformers can be used to provide a clean, isolated power source for sensitive equipment. They isolate the load from the transformer's primary side, eliminating any voltage imbalances or harmonic currents. The nature of the CNC machine's load and its sensitivity to voltage imbalances and harmonics should be carefully considered. Some machines may be more tolerant of these issues than others. The size and loading of the transformer should be verified to ensure it can adequately handle the CNC machine's power requirements and avoid overloading. It is important to consult with a qualified electrician and local electrical codes to ensure that the installation and operation of the delta-delta transformer complies with the applicable regulations. Using delta-delta with high leg transformers can introduce voltage imbalances, harmonic currents, and ground fault protection challenges. While removing the grounded tap may mitigate some of these issues, it is generally recommended to consult with the CNC machine manufacturer, an electrician, and review local electrical codes before making any modifications to the transformer. If necessary, consider using isolation transformers to provide a clean, isolated power source for the CNC machine. To further elaborate on these implications, let's delve into the specifics of each potential issue and recommended solutions. Firstly, consider the voltage imbalance created by the high leg configuration. In a 240 volts delta system with the high leg, 2 phases will measure 120 volts to ground, while the third, the high leg, will measure approximately 208 volts to ground. This is calculated by multiplying 120 volts by the square root of 3, which is approximately 1.732. This voltage imbalance can be problematic for equipment not designed to handle it, potentially leading to overheating, reduced lifespan, or even failure. Secondly, harmonic currents are a significant concern. Nonlinear loads, such as variable frequency drives commonly found in CNC machines, can generate harmonic currents that circulate within the delta winding. These currents don't flow back to the source, but instead create additional heat and stress on the transformer and connected equipment. This can lead to reduced efficiency, increased energy costs, and premature failure of the transformer. To mitigate harmonic issues, consider using harmonic filters or reactors specifically designed to reduce harmonic distortion. Thirdly, ground fault protection is crucial for safety. In a delta-delta system without a solid neutral ground, detecting and clearing ground faults can be challenging. The fault current may be limited, making it difficult for standard overcurrent protection devices to operate quickly and reliably. This increases the risk of electrical shock and equipment damage. One solution is to implement a high-resistance grounding system, which limits the fault current to a safe level while still allowing ground fault detection. Ground fault relays can be used to detect even small ground fault currents and trip the appropriate circuit breaker. Now let's discuss the implications of removing the grounded tap. While it might seem like a straightforward solution to eliminate the high leg and its associated voltage imbalance, removing the grounded tap can have unintended consequences. It converts the system to an ungrounded delta system, which can create its own set of problems. In an ungrounded system, a single ground fault won't trip a breaker, but it will raise the voltage of the entire system relative to ground. A second ground fault on a different phase will create a short circuit, potentially leading to a dangerous situation. Furthermore, removing the grounded tap may violate electrical codes and void the transformer's warranty. Instead of removing the grounded tap, consider using an isolation transformer. An isolation transformer provides a separate, isolated power source for the CNC machine. It isolates the machine from the voltage imbalances and harmonic currents present in a delta-delta system. The isolation transformer can be configured with a delta primary and a Y secondary, providing a solidly grounded neutral for the CNC machine. This ensures proper ground fault protection and eliminates the voltage imbalance issues. When selecting an isolation transformer, make sure it is sized appropriately for the CNC machine's power requirements. Consider the machine's inrush current, continuous load, and power factor. It's also important to verify that the transformer meets the relevant electrical codes and standards. In addition to isolation transformers, consider other power quality solutions such as surge suppressors and voltage regulators. Surge suppressors protect the CNC machine from voltage spikes and transients, while voltage regulators maintain a stable voltage supply, even during fluctuations in the power grid. Before making any changes to the transformer or electrical system, consult with a qualified electrician and the CNC machine manufacturer. They can assess the specific requirements of the machine and recommend the best solution for your application. Also, make sure to review local electrical codes and regulations to ensure that any modifications comply with the applicable standards. Furthermore, it is critical to consider the load characteristics of the CNC machine. Some CNC machines are more sensitive to voltage imbalances and harmonics than others. Consult the machine's manufacturer's specifications to determine its tolerance for these power quality issues. If the machine is highly sensitive, an isolation transformer may be the only viable solution. The size and loading of the transformer are also important factors. The transformer must be adequately sized to handle the CNC machine's power requirements without overloading. Overloading a transformer can lead to overheating, reduced lifespan, and even failure. Verify that the transformer's kVA rating is sufficient for the machine's load. Consider the machine's continuous load, inrush current, and power factor. It is also important to direct the transformer for ambient temperature and altitude. Finally, electrical code compliance is essential. The installation and operation of a delta-delta transformer must comply with all applicable electrical codes and regulations. Consult with a qualified electrician to ensure that the installation meets the code requirements. Pay particular attention to grounding, bonding, and overcurrent protection. In summary, using delta-delta with high-leg transformers can present several challenges, including voltage imbalances, harmonic currents, and ground fault protection issues. While removing the grounded tap may seem like a simple solution, it can create its own set of problems. Instead, consider using an isolation transformer to provide a clean, isolated power source for the CNC machine. Also, consult with a qualified electrician and the CNC machine manufacturer to determine the best solution for your application. Remember to review local electrical codes and regulations to ensure compliance. By carefully considering these factors, you can ensure the safe and reliable operation of your CNC machine. To reiterate some key points, the voltage imbalance in a high-leg delta system arises because one phase is center tapped and grounded. This creates two legs with 120 volts potential to ground, but the third leg, the high leg, has a voltage of approximately 208 volts to ground. This voltage is not compatible with many single-phase loads designed for 120 volts, and connecting such loads to the high leg can result in damage or failure. Harmonic currents are generated by nonlinear loads, which draw current in a non-sinusoidal manner. These harmonic currents can flow back into the power system and cause distortion of the voltage waveform. This distortion can affect the performance of other equipment connected to the same power system, including transformers, motors, and electronic devices. Harmonic filters can be used to mitigate harmonic currents by providing a low impedance path for the harmonic currents to flow. preventing them from propagating throughout the power system. Ground fault protection is essential for preventing electrical shock and equipment damage in the event of a ground fault. A ground fault occurs when a live conductor comes into contact with the grounded surface, such as the equipment enclosure or a metal conduit. In a solidly grounded system, a ground fault will cause a large current to flow, which will trip a circuit breaker or fuse, quickly disconnecting the faulty circuit. However, in an ungrounded system, a single ground fault will not trip a breaker, but it will raise the voltage of the entire system relative to ground. This can create a dangerous situation, as any other grounded surface can become energized. High resistance grounding can be used to limit the fault current to a safe level while still allowing ground fault detection. High resistance grounding involves connecting a resistor between the neutral point of the transformer and ground. This resistor limits the fault current to a few amps, which is not enough to trip a breaker, but it is enough to be detected by a ground fault relay. The ground fault relay will then trip the breaker, disconnecting the faulty circuit. When selecting an isolation transformer, it is important to consider the transformer's kVA rating, voltage rating, and impedance. The kVA rating should be sufficient to handle the CNC machine's load, including its inrush current. The voltage rating should match the voltage of the power system. The impedance of the transformer affects the voltage regulation and short-circuit current. A lower impedance will result in better voltage regulation but higher short-circuit current. Additionally, consider the transformer's efficiency, cooling method, and enclosure type. Efficiency affects the operating cost of the transformer. Cooling method affects the transformer size and noise level. Enclosure type affects the transformer's protection from environmental factors. When consulting with a qualified electrician, be prepared to provide them with information about the CNC machine's power requirements, the existing electrical system, and any specific concerns you have about power quality. The electrician can then assess the situation and recommend the best solution for your application. They can also perform load calculations, voltage drop calculations, and short-circuit studies to ensure that the electrical system is properly sized and protected. When reviewing local electrical codes and regulations, pay attention to the requirements for grounding, bonding, overcurrent protection, and wiring methods. Grounding ensures that all non-current carrying metal parts of the electrical system are connected to ground, providing a low impedance path for fault current to flow. Bonding ensures that all metal parts of the electrical system are electrically connected together, preventing voltage differences between them. Overcurrent protection protects the electrical system from overloads and short circuits. Wiring methods specify the types of conductors, conduits, and raceways that are allowed to be used in different applications. In conclusion, the use of delta-delta with high-leg transformers in CNC machine applications requires careful consideration of several factors, including voltage imbalances, harmonic currents, ground fault protection, and electrical code compliance. By understanding these factors and taking appropriate measures, you can ensure the safe and reliable operation of your CNC machine. Remember to consult with qualified professionals and adhere to all applicable codes and regulations. This will help you avoid costly problems and ensure the long-term performance of your equipment. Proper planning and execution are essential for a successful installation. Don't hesitate to seek expert advice and take the time to thoroughly understand the implications of your choices. This will pay off in the long run by minimizing downtime and maximizing the efficiency of your CNC machine. Furthermore, ongoing monitoring of the electrical system is recommended. Regularly check the voltage levels, harmonic distortion, and ground fault protection to identify any potential problems before they become serious. This can help you prevent unexpected failures and extend the life of your equipment. Implement a preventative maintenance program that includes periodic inspections, testing, and cleaning. This will help you keep your electrical system in top condition and ensure its continued reliability. Stay informed about the latest technologies and best practices in power quality and electrical safety. This will enable you to make informed decisions about your electrical system and keep it up to date with the latest standards. By taking a proactive approach to power quality and electrical safety, you can protect your investment and ensure the success of your CNC machine operation.